Hello, welcome to AP Calculus Lecture 5.9b. We're still going with inverse trig integration. You'll need your inverse trig formula sheet and also your unit circle available for this. This will be a short lecture, just doing a couple of more example problems. And I didn't include them on the last lecture just to make the video a little bit shorter. So we're going to do example 14 on, so we are still on page 390. So we're going from 0 to 1 over the square root of 2. Now 1 over the square root of 2 is the same as the square root of 2 over 2. Okay, you need to recognize that. It's just not rationalized. And we have arc cosine of x over the square root of 1 minus x squared dx. All right, so this doesn't fit any of these patterns right here, okay? None of these patterns have arc cosine in them, right? So hopefully you might recognize that this is just a standard u substitution. If we let u be arc, I do like this problem a lot, arc cosine of x, then du, if we look at the derivative formulas, du is going to be minus u prime over the square root of 1 minus u squared, which looks almost exactly like what we have here. So if we let u be x and u prime be 1, we would have 1 over the square root of 1 minus x squared, but it's minus u prime, so it's going to be negative 1 over that dx. And then if we bring this negative in front of du, it would be 1 over the square root of 1 minus x squared, which is exactly what we need. Okay, 1 over, or dx, right, don't forget the dx over the square root of 1 minus x squared. So don't forget the minus out front. We'll go from 0 to 1 over square root of 2. And all that would be left is just u. All right, arc cosine u du. So that's going to be minus 1/2 u squared, which is going to be minus 1/2 arc cosine x, all squared, evaluated from 0 to 1 over the square root of 2. So that's minus 1/2 arc cosine of 1 over root 2. Remember, that's the same as root 2 over 2, all squared, minus negative 1/2 arc cosine of 0, all squared. Okay, so this is going to be negative 1/2. If you look at your unit circle, remember it's root 2 over 2. That's going to be pi. Where's cosine root 2 over 2? It's at pi over 4. So we got negative 1/2 times pi over 4, all squared. Don't forget to square that. Plus, two negatives make a plus, 1/2. The angle whose cosine is 0 is pi over 2. All right, remember you can't pick 3 pi over 2. That's outside that domain restriction. We've got to pick answers between 0 and pi. Let's not forget to square that. So that's going to be negative 1/2 times pi squared over 16 plus 1/2 times pi squared over 4. So that's negative pi squared over 32 plus pi squared over 8. So let's multiply this second one times 4 over to 4, and that's going to be negative pi squared over 32 plus 4 pi squared over 32. And that's going to be 3 pi squared over 32. All right, so if you put that in your calculator, that's approximately equal to, that's not a very good approximately, is it? 0.925. All right, let's do one more, and this time I'm going to remind you how to complete the square. All right, so that takes you back to your Algebra 2 and maybe your pre-cal days. All right, so if you see in the denominator a trinomial, a perfect or a trinomial of second degree, all right, you've got an x squared in it. You might be able to move it into the arctangent territory. So this is example 22. All right, and we're going from -3 to -1 of dx over x squared plus 6x plus 13. All right, well that doesn't match any of our patterns on our sheet, but maybe we could rewrite this by completing the square into two square terms. So to complete the square, it's x squared plus 6x plus, and then just put a blank, and then plus 13, and then minus whatever we put in the blank. What you put in the blank here to make a perfect square is you take half the coefficient in front of x, so that's 3, and square it. So we add 9. And then, but then we have to subtract 9. Okay, so what we have here, if we were to factor now this perfect square, and then of course you'd have a plus 13 minus 9 is 4. Okay, you'd have x plus 3 plus 3. So that's the same as x plus 3 squared plus 4. Now we have what looks like the arctangent situation. -3 to -1 dx over x plus 3 all squared plus 4. So this looks like arctangent with a u of x plus 3, and thank goodness the du is 1, and a is going to be 2. So I'd have 1/2 going through the formula, arctangent u over a, so x plus 3 over 2, evaluated from -3 to -1. So that's 1/2 arctangent. If I put a -1 in here for x, that's 2 over 2, so that's 1. Minus 1/2 arctangent. If I put a -3 in here for x, it's going to be 0. So that's 1/2 times the angle whose tangent is pi over 4, is 1, is pi over 4, gave the game away. The angle whose tangent is 0, remember tangent is sine over cosine, so it's the angle whose sine is 0, and that's going to be 0. So that is pi over 8. Okay. So pause the video if you need to, and we'll go over the homework. The homework from this section is page 390. Got 1, 3, 5, 9, 11, 13, 17, 19, and 21. All right, so it's really 9, 11, 13, all of the odds except 7 and 15, looks like, on that. Okay, so that'll do it for section 5.9, and I will talk to you next video.